Chapter 4, Section 6.3, Part 1 video. In this section, you'll learn about graphing parabolas and looking at transformations and their effect upon the basic y equals x squared of a quadratic. So the first thing we're going to do is we're going to graph y equals x squared, and then we're going to compare it to what they're wanting us to, the transformation that they're wanting. Okay, so first things first, let's go get a calculator. Let's go y equals, clear there. I'm going to do the basic x squared as y1, and that's the one that we'll have throughout all these looking back. What effect is the new equation having on the basic quadratic? So there we go. Now we're going to hit graph. And of course you can't see much, so what I want you to do is hit zoom 6. And that zoom 6 should allow you to see everything that you need to on these transformations, okay? Or the effect that each transformation is having on the quadratic. So let's go back and look. Let's see. The blue, okay, so the blue is our original. So the 4x squared made the quadratic get skinnier. Okay. So let's go back. The parabola opens up. Yeah, it did open up. So we'll go there. Is standard shifted up by? Nope. Opens down. Note the parabola is standard shifted to the right, shifted down. Is 4 times the steep. Yep. And then, so that's F, or, yeah. And it's not shifted down. So let's kind of look at this. You're going to, in these transformations, you're going to look at ones that are reflected or opening down, and that would be, if you look at it in terms of ax squared, if the a is positive, it opens up. If the a is negative, it opens down, right? So that's one thing that the a does. And if the a is greater than 1, it gets, let's see, steeper. And if the a, now this is really the absolute value of a. Okay, and that really should be the absolute value there. It's going to get wider. Okay. All right. So that's kind of a little background on that with this problem. Now, the next one that we need to do says 4 plus x squared. So let's go grab. So we're going to take this and we're going to kill it. We're going to go 4 plus x squared. And we're looking at what is the red doing to it. So graph it. So the red is about the same size. Well, it is the same size, but it's just shifted up by 4. Now, in doing that, we need to look at a couple of things. This particular quadratic, so let's see, the parabola is shifted right by 4, nope. Shifted left, nope. 4 times as steep, nope. It does open up, okay. Down by 4, nope, it's shifted up by 4. So, the basic function is x squared. So if it's outside the function, it will go up or down. Okay, so this is what I mean by outside. Here's your function, x squared, right? This is outside the function. You could have wrote it like this, been the same thing. This is outside of it because here's your function. Now, let's look at another one. Let's look at this one. So, x minus 4. We'll clear there, open parentheses. X minus 4, close parentheses, squared. We're looking at the red. We're going to graph it. All right, so shifted to the right is what's happening. Okay, so this is inside function, okay? Because here's your squared, right? So if it is minus a number, it's to the right. If it's plus a number, it's to the left, because it's in the format of this, x minus a squared, right? And the a is the transformation, and the a is either going to be left or right. So it really changes the sign that's in there, okay? So it is opening up, and it's shifting to the right 4 units, okay? You could put x plus 4 and show that it's, and then look at it as in regards to that as well, okay? But I just wanted to kind of make sure that you're good by that. And there's more than one answer, right? Up or down, left, right. Well, opening up or opening down should be one answer, okay? And then you're going to look at it in terms of left, right, or vertical shift up or vertical shift down. Now, this one, let's go back and look. So we should know that it is outside the function, okay? If we graph it, we can just see that it's just been shifted down. Note that it didn't it did not, because the a is 1, right? And the a is the coefficient in front of the x squared. It did not change whether it was steeper or wider, right? It kept the same shape, but it just moved it down 4. So it's opening up, and it's going down by 4. There we go. So you can kind of play with all of these different transformations and whatnot. So just kind of be aware of that. Now, I'm going to work these two, and then this will be the end of part 1 of this video. But decide whether the vertex is maximum point or minimum. So if it's the A is 1/2 here, and it's a positive, so it's opening up, so it'll look like this, right? So that is a minimum. So it is a minimum. I can go ahead and tell you that. But we got to find its vertex. And what we're going to do is we're going to type it in, okay? And we're going to graph it, and then we're going to find its vertex. And we're looking at a minimum, okay? Now, parentheses 1 divided by 2, close parentheses, x squared. And I think that is minus 2/3, yep. Minus, parentheses 2 divided by 3, close parentheses, x, plus 2. And I'm just going to go graph. All right, so it's opening up, right? Now, we're going to go second trace, and we're going to hit 3 minimum. What we need to do is create a left bound and then a right bound. And we just want to be on either side, well, both sides, up one side on the left, up one side on the right. So we're encapsulating this lower minimum. And then we hit enter again, and we see that it is 0.667. And if we round that off correctly, that would be, well, it says they want points. So 0, let me go back. Here's the thing. They say points. Make sure it's ordered pair. 0.67. Okay. Note that I rounded it. And then 1.78. Okay. So there. It's a minimum, and that's where the vertex is. Now let's do the other one. The other one is going to be, let me go here, clear this. Y equals, clear, go back up, and it is 5 plus 2x minus x squared plus 2x minus x squared. All right, because the a, the coefficient in front of the x squared, is negative, it's going to open down, right? And most of these are still in just zoom 6, okay? Now, it's opening down, that's the negative a, and now we're going, that would be, because the a is negative, right? The a happened to be -1, so it's going to open down. There's our vertex, right? So it's going to be a maximum. So if the a is negative, it's opening down, it's going to be a maximum, okay? Now all we got to do is come over here and go second trace. Now we're going to hit number 4 for maximum. Hit enter for left bound. Enter for right bound. I don't want to be up at the very top. I want to be down each side just a little bit. And then I'm going to hit enter again, and it'll tell me that the maximum is at 1.6. And again, I want to put those as an ordered pair. Okay, so there you have chapter 4, section 6.3, part 1 video.